Friends, hello. Well, the moon continues to be a hot destination for everyone eager to explore space. In February 2025, for the first time in history, 3 space missions were heading to our satellite simultaneously, all of them representing private companies. One of the landers demonstrated what it means to achieve a soft landing, another was slightly less fortunate, and the third will attempt its landing in May. Thus, this new phase of commercial expansion to the moon has been rich in exciting events, which we will analyze in detail today. And of course, we will pay special attention to the Blue Ghost 1 mission by Firefly Aerospace, which has taken a truly significant step forward in the role of private companies in space exploration. More than $2.5 billion. This is how much NASA has allocated for its Commercial Lunar Payload Services, CLPS, program. Private companies are competing for this funding, aiming to build spacecraft that will deliver payloads to the lunar surface for the agency. Since NASA plans to send humans to the moon and establish conditions for long-term stays, involving private companies is expected to significantly reduce the burden on the agency, especially on its budget. The main role of private companies is to lay the groundwork for human missions. Each commercial lander must conduct scientific experiments on the surface and test technologies that could potentially be used by astronauts. However, the primary goal remains the delivery of critical cargo, without which human presence on the moon would be impossible, and this delivery must be cost-effective. NASA's approach to commercial missions is fundamentally different from its traditional mission strategies. Essentially, the agency only provides funding and offers recommendations on landing sites and desired payloads. Everything else, construction, operation, and mission management, is entirely the responsibility of private companies. And this was an opportunity that many space players were eager to seize. In 2018, 9 U.S. companies signed agreements with NASA, and a year later, 5 more joined the program. The first to test its capabilities was Astrobotic, which launched its Peregrine lander in January 2024. However, due to a fuel leak, it never reached the moon, and operators had to safely redirect it back into Earth's atmosphere. Just a month later, the Houston-based company Intuitive Machines made its attempt. Their 6-legged, 4-meter-tall, 1.57-meter-wide lander, named Odysseus, belongs to the Nova C class of landers. It was launched on February 15, 2024, aboard a SpaceX Falcon 9 rocket, reaching the moon in 6 days. However, the landing turned out to be quite challenging. During descent, it was discovered that laser altimeters were not functioning, preventing the lander from accurately measuring its altitude and lateral velocity. Although engineers attempted to use lasers from the scientific payload, their efforts were only partially successful. As a result, Odysseus had to land based solely on optical data. Instead of a controlled descent at 1 meter per second, the lander was descending 3 times faster, with an additional lateral motion of about 1 meter per second. Consequently, Odysseus landed 1.5 kilometers away from the planned site, making a rather rough contact with the surface. Essentially, it scraped the lunar regolith with its landing legs, breaking at least one of them. However, it managed to come to a stop in a vertical position. For a short time, the lander stood on its own legs, but once its engines shut down, it gently tipped over onto its side. While this couldn't exactly be called a soft landing, Odysseus is still considered the first American spacecraft since the Apollo era to successfully execute a controlled descent onto the moon. Later, it was revealed that the navigation issue was caused by human error. The flight preparation team failed to manually unlock one of the safety switches before launch, preventing the laser altimeters from activating. Nevertheless, despite its unfavorable positioning, the lander's solar panels still received some energy, and all 6 NASA scientific instruments managed to collect and transmit valuable data. Thus, the mission was ultimately declared a success, making Odysseus the first privately built and operated spacecraft to land on the moon. Without a doubt, this marked the beginning of a new era in space exploration. Thus, at the beginning of 2025, NASA's Commercial Services program had only 1 successful mission out of 2, or, to be frank, 1 semi-successful mission out of 2. And now, finally, in February-March, we awaited the continuation of this saga. Let's start with the fact that Intuitive Machines attempted to surpass its previous result, and this time execute a precise and soft landing, leaving no room for doubt. In reality, their new attempt had significantly higher ambitions, as the lander named Athena was loaded to the ears with expensive scientific equipment. NASA aims to study the lunar South Pole more thoroughly, where, as you know, orbital probes have found water ice. This is a valuable resource, since water can not only be drunk, but also converted into rocket fuel. Therefore, the main task of the IM-2 mission was to directly confirm the presence of ice. For this purpose, NASA provided an instrument called Prime 1. It includes a special drill that was supposed to bite into the lunar ice and a mass spectrometer for measuring the number of ice particles in the samples. The device could drill to a depth of up to 1 meter, and this was to be the first demonstration of such technologies on the Moon. In addition, there was an ambitious goal to deploy and test a cellular network on the Moon. NASA and Nokia signed a contract to test fourth-generation technologies. It was expected that, using this network, the lander would communicate with 2 small rovers tasked with searching for water ice. So, clearly, the IM-2 mission could have become an important step in the development of the Artemis program. Structurally, Athena also belongs to the Nova C family of landers, making it almost a twin of Odysseus. As stated by Intuitive Machines, they only slightly modified certain design elements. First of all, changes affected the activation system of the laser altimeter, which had failed last time, and the software was updated. And although this time the goal was not just a successful landing, but also to carry out an important water search mission, as you probably know, not everything went as planned. The launch took place on February 27, 2025, aboard a Falcon 9 rocket. Along with Athena, other interesting missions were launched, including NASA's Trailblazer and a small probe, Odin from Astroforge. Trailblazer was to join the Moon's orbiters, while Odin was headed to one of the near-Earth asteroids as part of the first phase of space mining. However, both almost immediately lost contact with Earth, and their fate remains unknown. Meanwhile, Athena steadily traveled to the Moon and sent back stunning photographs of Earth. After a few days, the spacecraft entered orbit around our satellite, completing a total of 39 orbits. It continued sending a great number of beautiful images to Earth, allowing us to enjoy magnificent views of the lunar landscape, including the South Pole. Finally, on March 6th, the mission team attempted the descent. Well, the landing did take place, but considering the amount of energy the spacecraft received after touchdown, the forecasts regarding its condition were not very encouraging. The CEO of Intuitive Machines stated at a press conference that, judging by the data, they do not believe the module could have landed on its legs and that it most likely is lying on its side again. And in that position, Athena cannot receive enough solar energy. Well, the next day everything became clear. This photograph, which can now be called historic, shows us a spacecraft peacefully resting on the lunar surface, with the disk of our planet in the background, a landscape that seems to aptly characterize the successes of NASA's commercial initiative for lunar exploration. At the time this video was created, the investigation into the cause of Intuitive Machines' second failure was still ongoing, but it appears that the laser navigation system once again did not function properly. The spacecraft likely did not understand its altitude or its lateral velocity. Of course, no scientific experiments could take place, but NASA still managed to obtain some scientific data before the mission was officially concluded. Specifically, the drill was activated and performed several movements, at least demonstrating its ability to function in the space environment. The 4-wheeled lunar rover also responded to commands, confirming its integrity and indicating that it could have carried out its mission if the landing had been successful. Indeed, the lunar South Pole is a challenging location for exploration, as communication is quite limited, and the sun's angles restrict the ability to collect solar energy. Moreover, it is an uncharted region with a difficult terrain, which, incidentally, could have also contributed to the failure. However, Athena did achieve one thing. The spacecraft managed to land just 250 meters from its target point, making it the closest spacecraft to the lunar South Pole to date, only 160 kilometers away. As a reminder, this is the very location where NASA plans to land astronauts for the first time since Apollo 17. As for Intuitive Machines, despite losing equipment worth tens of millions of dollars, the company still has at least 2 more NASA contracts for cargo deliveries. However, they now face the difficult task of identifying and resolving the causes of their failure, which this time was particularly painful. In fact, had it not been for the successful landing of Blue Ghost 1 just a week earlier, Athena's failure would have been a much bigger blow to NASA's Commercial Services initiative. But fortunately, alongside major failures, there were also remarkable successes. On January 15, 2025, a Falcon 9 rocket launched 2 spacecraft to the moon. One was Blue Ghost, developed by the private company Firefly Aerospace, and the other was Resilience, from a Japanese private company called iSpace. iSpace is not involved in NASA's commercial contracts, but this is already the company's second attempt to send a spacecraft to the moon. The first attempt was in 2023 when the Hakuto R lander crashed during landing. Therefore, Resilience has chosen the most energy-efficient route to the moon, which also means a rather long journey, with the landing attempt expected at the end of May or in June. If everything goes well, we will also take a closer look at this mission. Meanwhile, Blue Ghost 1, from Firefly Aerospace, marked the company's debut on the moon. According to Firefly's director, during the design and construction of their lander, they drew inspiration from various sources, including closely observing Israel's Bereshit mission, which reached lunar orbit in 2019, but unfortunately crashed during landing. Allensworth, Firefly's director, noted that his team learned valuable lessons from that mission. The spacecraft they managed to build stands approximately 2 meters tall and 3.5 meters wide, with 4 landing legs, and at first glance, it appears significantly more stable compared to the tall and slender Odysseus and Athena. The lander was named after rare fireflies. After a successful launch, the lander spent 25 days in Earth's orbit, conducting system checks and part of its scientific mission. Eventually, it embarked on its journey to the moon, which lasted about 4 days, and entered orbit around our satellite, where it remained for another 15 Earth days. The descent began on March 2nd, when the spacecraft fired its engines to maneuver onto its landing trajectory. The chosen landing site was the Mare Crisium, located in the northeastern part of the moon's near side. For about 50 minutes, the lander continued its uncontrolled descent toward the surface before reigniting its engines to reduce orbital velocity and position itself over the designated landing area. 9 minutes later, it shut down its main engine and entered the terminal guidance phase. During this phase, the module's control system continued firing small thrusters to fine-tune the descent as precisely as possible. The spacecraft automatically selected the smoothest available landing area with the fewest boulders. According to Firefly, the lander performed 2 automatic hazard avoidance maneuvers, demonstrating the reliability of its software. Finally, a successful landing was confirmed. However, the moment was not without tension, as not all landing leg sensors confirmed surface contact. At least one of the 4 failed to transmit that information. Nonetheless, any doubts were quickly dispelled. The spacecraft was indeed standing on its legs and had executed a successful soft landing within just 100 meters of the expected touchdown site. 40 minutes later, the mission team published the first image from the surface, clearly showing lunar regolith and part of the spacecraft's body. Interestingly, local lunar daytime had just begun. The sun was rising over Mare Crisium, allowing for stunning images not only of the sun itself, but also of the large shadow cast by the lander. This meant that the mission team had a full lunar day, equivalent to 14 Earth days, to complete all planned operations. The mission was not designed to survive the freezing lunar night, so once the sun set, the spacecraft would not only stop receiving energy, but would most likely freeze. That meant there was a lot to accomplish within 2 weeks. Overall, the Blue Ghost lander carried as many as 10 NASA scientific experiments, the most for any commercial mission to date. As mentioned earlier, some of them began operating immediately after launch. While in Earth's orbit, the spacecraft measured solar particles and studied how the solar wind interacts with our planet's magnetic field. Even during the high-stakes landing sequence, science was taking place. The stereo cameras for Lunar Plume Surface Studies CLPS instrument closely recorded every detail of the touchdown. This set of stereo cameras was designed to gather data on how the lander's engine plume interacted with the lunar regolith. Currently, very little is known about how exhaust gases affect the local soil under the Moon's low-gravity conditions. However, this data is crucial for designing the next generation of lunar landers, especially those that will transport humans. For context, during the Apollo 12 mission, the Eagle lunar module landed just 150 meters from the Surveyor 3 probe, which had been sent to the Moon earlier. When astronauts approached the unmanned lander, they discovered numerous impact marks on its body from tiny rocks, and even punctures caused by larger debris, which had been blown away by the Apollo module's descent engine. To put this into perspective, Apollo landers were around 7 meters tall, whereas Starship, which will return humans to the Moon, stands at 50 meters. That means it will kick up far more debris than its predecessors. This is why understanding and predicting the effects of lunar landings is so important. Some design solutions may help minimize potentially harmful consequences. The stereo cameras successfully collected the necessary data and fulfilled their mission. Following touchdown, the spacecraft deployed its antenna toward Earth to enable the rapid transmission of high-definition images and videos. On March 4th, 2 days after landing, NASA released a list of scientific operations that had already been carried out. For example, the electrodynamic dust shield was successfully tested. As you may know, lunar dust was one of the unpleasant surprises during the Apollo missions. It stuck to practically everything. Unlike Earth's dust, lunar dust is abrasive, resembling tiny shards of glass, since it doesn't undergo wind or water erosion, making it inherently hazardous. Moreover, it can accumulate on critical equipment, including astronauts' suits. If this dust enters a habitat module, astronauts could inhale it, posing serious health risks. One method to combat this problem is the creation of an electrodynamic barrier. Essentially, an electric field repels dust particles, allowing surfaces such as solar panels, radiators, and, of course, spacesuits to be cleaned effectively. The testing of this technology on the Moon was also successful. The next interesting experiment could be called a lunar vacuum cleaner. For future human missions to the Moon, Mars, and possibly other celestial bodies, NASA aims to make surface sample collection as simple and efficient as possible. Enter Lunar Planet Vac, a new pneumatic system concept that eliminates the need for digging or drilling by directly collecting the required amount of soil. The device releases compressed gas to stir up regolith and then simply vacuums up the resulting debris cloud, capturing particles up to 1 centimeter in size. This technology was also successfully tested, and let's be honest, we have to thank the Firefly team for the wealth of detailed videos that allow us to witness all of this firsthand. Another tested technology might be one of the most crucial in this mission, as it dealt with navigation. As you may know, the Moon does not yet have its own GPS satellite network. To address this, NASA and the Italian Space Agency attempted to use Earth's global satellite system for positioning on the Moon. The idea is that satellites orbiting our planet send out broad beams for triangulation and location determination on Earth's surface. However, some of these beams are wide enough to extend beyond our planet and are strong enough for receivers on Blue Ghost to detect. And they did. The GNSS receiver experiment, LUGRE, successfully captured GPS signals at an unprecedented distance, about 400,000 kilometers from Earth. The previous record was held by the Magnetospheric Multiscale (MMS) mission, which in 2019 received GPS signals at 187,000 kilometers from Earth. As you can imagine, space communication and navigation systems will play a vital role in missions beyond Earth. That's why a functioning GPS on the Moon is truly an incredible achievement. On March 6th, in a blog post on the Firefly website, the mission team announced that 8 out of 10 NASA scientific experiments had already achieved their goals. Among them was the successful testing of a pneumatic gas drill, LISTER. Its task was to drill 2 to 3 meters into the lunar soil and place a needle-like temperature sensor at the bottom. The experiment involved initially measuring the soil temperature for 1 hour, after which the needle began heating up to track how the lunar regolith absorbs heat over time. This data is crucial for understanding the thermal conductivity of the local soil, how well heat flows through it, and how temperature changes with depth. On March 7th, Firefly published a video showcasing the impressive deployment of an instrument called the Lunar Magnetotelluric Sounder, LMS. It consists of a 2.5-meter magnetometer mast and 4 electrodes, which are launched 20 meters away using a spring mechanism. This device measures variations in the electric and magnetic fields on the lunar surface. Such variations occur due to fluctuations in the solar wind and the influence of Earth's magnetosphere. By analyzing these natural field variations, scientists can determine how easily electricity flows through the moon's subsurface materials. In turn, this helps uncover the internal composition of the moon and its thermal history, providing insights into its formation. A similar experiment was conducted during the Apollo missions, but this version is an upgrade with potentially better results. As the days passed, Blue Ghost endured the harsh lunar midday, when surface temperatures can reach plus 121 degrees Celsius. During this time, the mission team adjusted its power levels to prevent overheating. Each passing day on Earth brought a shift in the sun's position on the moon, from zenith toward the horizon, and by March 12th, nightfall had begun in the Sea of Crises. Since the end of the lunar day marked the conclusion of Blue Ghost's mission, everyone eagerly awaited its final images, which promised to be truly unique. Why? Because on March 14th, Earth, the Sun, and the Moon aligned in such a way that our planet passed directly between the Sun and the Moon. For observers on Earth, the Moon appeared covered by Earth's shadow, taking on a reddish hue, what we call a blood moon. However, for observers on the Moon, an entirely different phenomenon occurred, a total solar eclipse. These images have already made history as the first ever solar eclipse captured from the Moon's surface. Notice how everything around turns red as Earth's disk begins to block out the sun, a truly breathtaking sight. Finally, on March 16th, as the sun dipped below the horizon, Blue Ghost captured its last images, marking the official end of the mission. And what a stunning ending it was. Without a doubt, this was a 100% successful mission, or perhaps even more than 100%. Blue Ghost landed safely, activated all scientific instruments, successfully conducted all experiments, and wrapped up its mission so epically that it will be remembered for a long time. While Firefly's success is truly inspiring, as of the time of this recording, NASA's Commercial Lunar Payload Services has seen mixed results. 2 failures, 1 partially successful attempt, and 1 fully successful mission out of 4. Some might see this as a risky strategy, but this approach actually saves a lot of money and accelerates lunar exploration. So, while Elon Musk focuses on Mars and largely ignores the Moon, it is his rockets that have become the key to modern lunar exploration. And things are about to get even more exciting. By the end of this year, 2 new missions are expected: the Griffin lunar lander by Astrobotic and Intuitive Machines' 3rd attempt. So, share your predictions. Will we see a smooth landing this time, or will the spacecraft end up on its side again? And, of course, let me know your thoughts on the incredible Blue Ghost mission. I think it's one we'll all remember for a long time. That's it for now. Thank you for being here. Subscribe to this channel so you don't miss the next videos in this series, and hit like if you enjoyed this content. See you in the next episode, and take care.